In this video, we're going to start talking about techniques for solving different types of equations. And in this first lesson, I want to talk to you about using factoring to solve equations. And I actually have an example from homework that we're going to do a little bit later on. We'll do one or two examples before we get to it. But before we even do that, I want to talk to you about the idea. So the idea of using factoring to solve equations rests in this property. It's called the zero product property. You'll actually probably hear it called other things also. This is not like a hard set name. You'll maybe also hear it called the zero property of multiplication, or some property of zero, multiplicative property of zero. So don't get too attached to that specific name, rather the idea behind it. So the idea behind it is that if the product of two things is zero. And I can't stress enough the importance of the fact that this is zero. This is not true for any other number. But if two things multiply to zero, then one of them has to be zero. And really, it would be more correct to say then at least one of them has to be zero. Because, for example, if you're multiplying a thing by itself and you get zero, the only way that happened is if that thing was zero. So both of the factors would be zero in that case. So I want to kind of, the way that I have before, I want to do a few examples that sort of, escalate in difficulty. So let's say that we have x times x minus 7 is equal to 0, right? So if it's helpful, you may find this helpful, you may not care, but what we're saying here is that, going back to our idea from above, x is playing the role of A and x minus 7 is playing the role of B. So I'm telling you that if these two things multiply to 0, that happens either when x is 0 or when x minus 7 is 0. So we set both of them to 0, and if you want, you can write the word or between them, and you see clearly, well, x is equal to 0 if the value of x is 0, so that gives us the first solution. And then x minus 7 is 0. So here, if you want, you could use the additive property of equality, right? So get x by itself. But I also want to encourage you to think about the fact that what you're being asked here is, what would you take away 7 from and then end up with nothing? Okay, so I'm going to use that because I want to encourage you guys to be thinking sort of critically rather than going and reaching for rules and processes with every problem. But if you want on your own time to also walk it through with the addition property of equality, you absolutely can. So x minus 7 is 0 when x is 7, because 7 is the only number that you would take away 7 from and then end up with nothing. So there's our solution, and really we should call it solutions plural. And if you want, you can put it in little curly brackets like this. We use curly brackets when we have a collection of things that's finite and that we can list. Okay, so that's our first example. Now let's try a second example. So say we have something like 2x squared minus 7x minus 4 is equal to 0. Okay, so in this case, this harks back to our video on factoring quadratics. So 2x squared minus 7x minus 4 is not factored. It's in its kind of default quadratic form. So the first thing we're going to do, and I'm going to write this in red, the first thing we're going to do is we're going to factor 2x squared minus 7x minus 4. So again, this is a little bit the way that we've been talking about trial and error. right? But we know that it has to be 2x and x. Notice that I'm sort of assuming that this factors. Yes, I should always have that back in my head that, well, what if it doesn't? In fact, I'll mention at the end of this video, well, what is my recourse if it doesn't factor? But for now, we're going to assume that we're dealing primarily with problems where factoring works as a solution. Okay, so what do we have here? So we know that the first two terms have to multiply to 2x squared because, and therefore it'll be 2x and x. Now the constant has to multiply to -4. So there's a lot of different techniques you can use here, but I'm going to skip straight to the chase. The 4 cannot live with the 2x. That's not possible. Why not? Because if there was a 4 in this factor, whether it be 2x plus 4 or 2x minus 4, there would be a common factor of 2. And you can look back at your original expression, 2x squared minus 7x minus 4, and it does not have a factor in common between all three terms. So we can rule out the 4 living in the same term as the 2x pretty quickly. So the 4 has to live here, and that means that 1 has to live here. By the way, you'll notice I didn't even try the possibility that it's 2 times 2 for 4 for the exact same reason. Because if we were doing 2 times 2 to get that 4 at the end, for sure there would be a common factor, and we didn't have one. So from here, it's just a matter of who's positive and who's negative. Either the 4 or the 1 has to be negative because they have to multiply to -4 in the end. But which one? Well, remember, and I've said this before, the -7x gets the last laugh. Like, that's what really gets the deciding vote. So you're trying to create a -7x. And let's just, for a second, pretend that it was x plus 4 and 2x minus 1. Well, then 2x times positive 4 gives you positive 8x, and -1 times x, that just subtracts an x off, so the sign's off. So it's a pretty quick check to see that, in fact, it's x minus 4 times 2x plus 1. From here, we're home free because we use the zero product property, and that tells us that either 2x plus 1 has to be 0, or x minus 4 has to be 0, which means that x is 4, right? Again, we're asking what would you subtract 4 from and end up with nothing. So that's 4, and then 2x plus 1 equals 0. So you can reverse engineer this, and I actually encourage you to do that, but let's walk it through. So to get the 2x by itself, we'll subtract 1 from both sides, which gets us 2x is equal to -1. And then from here, if you can see it, great. If not, you can divide both sides by 2. And so you'll get that x has to be -1/2. So again, we have two solutions. And the solutions are -1/2 and 4. Okay. All right, so good. So let's try another example. So this is the next example, and this is the problem from homework. So this tells us, find all the real solution of the equation. By the way, just in case you can't see, this is problem number 10 from homework 1. You'll notice that some of the numbers are in red. That's because WebAssign will randomize. So some of you will have a slightly different version of this problem, but conceptually it'll be the same for everybody. So take good notes. Okay, so what I'm kind of hoping, and this is part of why I was so excited to pick this problem, is that this rings a bell for you all. You're looking at this and you're like, wait a minute, we factored this thing back in the video about factoring by grouping. And in fact, we did. So let's use factoring by grouping here. And I'm just going to go ahead and do it from scratch. There's nothing wrong with a little tiny bit of review. So I have x cubed minus 4x squared minus 7x plus 28 is equal to 0. And I'm going to use my trusty 2 and 2 grouping. So the first two terms and the second two terms. And again, remember, we're always kind of keeping an eye out for the sign between the two groups. And here it's a minus. So whatever we do with the second group, we're also going to factor -1 on top of it. First group, we can pull out x squared. Okay. Times x minus 4. And then we can pull out -7. And again, since we're factoring out -7, we will once again end up with x minus 4 because you're asking what would you multiply by -7 to end up with positive 28. As I'm thinking back on it, maybe this is very similar to an example we did in the grouping lesson, but not identical. So I don't want to confuse you all. Okay, so from here, I guess I'll just kind of point out this is a successful grouping. Remember, we got all kind of celebratory about it in our video on factoring by grouping because both of the groups end up having x minus 4 as a factor. So we're going to factor out x minus 4, which leaves us x squared from the first group minus 7 from the second group. So this is kind of a cool example, in my opinion, because we get to see something we haven't seen before. And I'll tell you kind of what it is in a minute. So I'm actually not going to bother trying to factor x squared minus 7. I welcome you to try, but you'll notice it won't work. And you'll see why in a second. So we set x minus 4 to 0. We're using our trusty zero product property. So this big purple idea that I started with, that's really governing this whole conversation. So x minus 4 is 0, so who would you subtract 4 from and end up with 0? So that's 4. And now we come to this. So those of you who are enjoying the reverse engineering piece, you could try to think about it just without writing anything. But what I'm asking you here is, can you think of a number, or more than one number possibly, that after you square it and subtract 7, you have nothing left? Well, let's kind of backtrack a minute. So after you square it and subtract 7, you have nothing left. That means that before you subtract 7, after you squared it, you had 7. So, in other words, you can think of it as using the addition property and adding 7 to both sides, right? So now we're thinking about whose square is 7. So you could say, and you would be absolutely correct, 7 is not a perfect square. There isn't a nice number whose square is 7, and that's absolutely true. But who said anything about nice, right? A number doesn't have to be nice in order for us to square it. So what I want to remind you is I want to remind you about the number square root of 7. The square root of 7. And then the other thing I want to remind you of is that when you square a number, you're multiplying it by itself. So whether you're squaring a number or its opposite, so the negative version of it, you're going to end up with the same thing. So not only can x be the square root of 7, it can be the positive or the negative square root of 7. So this is an example of a problem that actually has 3 solutions. For the positive square root of 7 and the negative square root of 7. So I want to real quickly, before we move on to the next example, I want to just kind of take you back here to the statement. So the statement of this problem says find all real solutions of the equation, right? So I'm looking at this piece here. So notice it doesn't say find all whole number solutions. It's not saying find all the rational solutions. It's fine with any number as long as it's real. And for a long time to come with our journey, we're not going to deal with any numbers that aren't real. So basically any number is fine, including square root of 7. I want to start an example that I am going to encourage you all to kind of poke around with on your own. And incidentally, I will do that in my videos sometimes, kind of give you an example that I'll start and then encourage you to think about on your own time. And really important to actually take me up on that, because that's the sort of thing that we could maybe talk about in our meetings on Friday. You could bring it up as a question. I might talk about it to sort of see how you all did. So please heed those invitations. Okay, so here's an example. Say that we have x times x minus 5 is equal to 6. Okay, so here's the thing, and I'm going to do this in orange. Caution. This is a biggie. This is a big important one. If A times B equals 6, you know virtually nothing about A and B individually. So in particular, if A times B is equal to 6, that does not mean that A has to be 6 or B has to be 6. It frankly doesn't mean anything about A or B on their own. Together they multiply to 6, but individually we've basically said nothing. Why do I say this? Well, I say it because it gives me an opportunity to take us back home to our friend, the zero product property. The only number that has this powerful insight packed into it is the number 0. That if you multiply two numbers and you don't know what they are, but they multiply to 0, immediately you know that one of them, at least one of them, has to be 0. So what happens when you have this? Well, you need to start by setting one side to 0. So I'm going to say one side because it's not always going to be the right-hand side. But of course here it's easier to just subtract 6 from both sides and set that side to 0. So I'm going to subtract 6 from both sides. And then I have this weird looking thing. X times x minus 5 minus 6 is equal to 0. So remember, this is a conversation about factoring. And right now I have this weird kind of sequestered product in the left-hand side. So what I'm going to go ahead and do in order to be able to use my factoring techniques is I'm going to go ahead and distribute the x through. Okay, so in fact, that x times x minus 5 turned out to be a bit of a red herring. It looked like maybe the problem was saving us time, like, oh, it came pre-factored. But in fact, because it wasn't set to 0 on the right-hand side, the x times x minus 5 just made our lives harder, not easier. All right, so after we distribute, we have x squared minus 5x, and then, of course, minus 6 is equal to 0. So now we want to try to factor this. So let's see, we don't have a greatest common factor other than 1. And again, we're assuming that this will factor because so far that's been the goal of the conversation, although I will end with an example where it doesn't. So from here, I think you guys can take it. So I'm going to say you take it from here. So all we have left to do is finish the factoring and then find the solutions to the equation. But finish it up and see how you do. I want to say a couple more things before I finish this video. So let's say that you're doing this and you're getting a bit turned around and you're losing sight of what it is that you're here to do. I highly, highly recommend to check your solutions. So in the interest of time, I'll go back to our second example and I'll just check one of the solutions. But honestly, I highly recommend that you take the time and go through and check all of the solutions that we came up with. And it would be a cool challenge for you all to check the plus or minus square root of 7 in our third example. I think that would be a cool thing to do, and I encourage you to give it a shot. All right, so let's check 4. So as you remember from our very first video on what is an equation, for something to be a solution would mean that if we substitute it in place of the variable piece, that the statement would hold true. So in other words, if I plugged 4 in for x, I'd get 0 on both sides. Well, let's see, moment of truth, right? So 4 squared is 16. 7 times 4 is 28. Minus 4. Maybe let's put a little question mark on top of our 0. So what do we have here? 2 times 16 is 32, minus 28, minus 4, and that is in fact equal to 0. So yay, that's a good thing. So I think it would be really great for you all to test -1/2, especially since a lot of the time we have some difficulties working with fractions. I highly encourage you to give it a whirl. Bring me questions if you have them on Friday. But for now, we'll move on from this just by me saying I encourage you to check your solutions. So we will end this conversation with kind of the million-dollar question. What if factoring doesn't work? And unfortunately, if factoring doesn't work and you have a polynomial equation like the kind that we've had in these examples, you're mostly out of luck. So once you guys get to calculus, you'll talk about some ways of approximating solutions. So there are some pretty cool ways to do that. And in fact, in practice, we use those techniques a lot because factoring doesn't always work. But if the equation is quadratic, you can use the quadratic formula. Now, I know as soon as I say this, this is kind of like the floodgates. I know that there are some of you who are thinking, oh yeah, quadratic formula, I know that. I'm just going to use it all the time. Forget factoring. And I want to caution you against that for several reasons. But the first one is factoring by grouping is not going to be substituted by the quadratic formula. If something can be solved by factoring by grouping, the quadratic formula won't help you. And then the other reason is the quadratic formula has a lot of moving parts, and it's very easy to make a mistake if you're not super experienced and super careful. So factoring actually turns out to be neater and faster in a lot of cases than the quadratic formula would have been. So I highly encourage you to try to factor first. You'll notice the more you try, the faster you'll get at it. And then if factoring doesn't work, and it's a quadratic equation, then go ahead and use the quadratic formula. So this is our first of several videos on solving different types of equations, and I will see you in our next lesson. Bye.